Hi, and welcome to part 4 of the CNC retrofit for my EMCO Turn 50 CNC lathe. In this video I will be covering the controller housing, a lot of polishing and the replacement of the external e-stop, including ladder modifications to make it work. I needed a place for the new CNC controller, but my lathe is so small that there is no way I could integrate this into the housing of the lathe itself. I bought a plastic enclosure that would fit the controller and be deep enough to accommodate for the cables coming out of the back. I know that many people prefer a metal enclosure for rigidity and EMI, but I am using a plastic one since it is light, easy to work on and less expensive. It was only around 50 euros at Amazon. There's a link to all parts used in this build in the description below. Using an electronics enclosure in this orientation is a bit unconventional, but it allows for easy access to the cables when it's mounted above the lathe. Simple household tools can be used to cut the plastic. I'm using an oscillating tool, but also a hacksaw can be used to make the cuts by hand. Any remaining burrs can be filed away. No need to have a super clean edge, as any imperfections will be covered by the front panel of the controller. I made a couple of round holes in the enclosure as well, for ventilation and cables. For the ventilation holes I will add a fan later. The set of hole saws came from IKEA and is not designed for plastic, but they work fine, except for some molten burrs that I had to remove manually. Next I had to figure out how to mount this controller box to the lathe. Again I went for an off-the-shelf solution by using a standard Visa mount, typically used for TVs and monitors. The metal backplate also received the same hole pattern, so I could use that to create some additional rigidity. A couple of aluminum square tubes were placed in between as spacers. I have mounted a DIN rail as well, which will be used for wire terminals. The controller is mounted to the front panel with 6 bolts. Here you can see the downside of a plastic enclosure. The gasket of the CNC controller pushing into the front panel was causing ugly looking gaps. Since I was already invested in this enclosure, I decided to fix this with some aluminum brackets. When these are placed behind the front panel, they eliminate the gap almost completely. Initially I had planned to mount the CNC control box on the side of the lathe, something like this. I tried using a monitor stand for this, but it turned out to have several issues. The arm itself was bending under the load, and also the housing of the lathe would have to be reinforced to prevent it from flexing. In the end I just ended up mounting a TV arm to the wall behind the lathe. Unfortunately this means it will have to be removed when I'm moving the lathe, so it's not ideal. Next up were some cosmetic fixes. The powder coat was in a poor state and had a lot of scratches and stains. The same goes for the plastic door, especially around the cutting area of the lathe. I think the plastic is polycarbonate, but I'm not sure. Regardless, my plan was to clean it and polish it so it would be usable again. This process is quite scary because it will get a lot worse before it gets better. And you can no longer buy these types of covers, as far as I know. For this job I'm using a plastic polishing kit with a coarse and a fine polishing compound. They are called heavy cut and fine cut. The number next to the label is a bit confusing, as the higher number is the coarse variant and the lower number is the fine variant. This is the opposite of sandpaper, where the higher the number, the finer the grit. The idea is to do wet sanding with 400 grit sandpaper to remove deep scratches, followed by even finer grit sandpaper, and then to polish it with the heavy cut, followed by the fine cut polishing compound. The heavy cut bottle says it is able to polish out 2000 grit sandpaper marks. Because I did not have sandpaper this fine, I ignored the instructions and tried polishing out a surface left by a 1000 grit sandpaper, which is already quite fine. This turned out to be quite a disappointment. I spent a huge amount of time trying to get a good surface finish without any success, because the sanded surface was simply too rough to finish up with the polishing paste. I ended up buying a set of fine sanding paper online and even sanded the door with finer grit than recommended. I went up to 5000 grit. This made a huge difference. It created a decent finish even with the coarse polishing compound. The last step was to finish it off with the fine cut polishing compound. This was done after thoroughly cleaning the part and by using a different polishing pad to avoid contaminating it with the coarser particles from the heavy cut compound from the previous step. The end result is a very nice, perfectly transparent surface. When you look closely, there are still small scratches left on the surface, which can probably be removed with even more effort, but for me the finish is perfectly fine. And also I had no arms left at this point, so my judgment was probably not completely unbiased. The next item on the list was cleaning and polishing of the power-coated parts. Since the panels were already heavily stained and scratched, I did not mind taking a risk. I used an abrasive cleaner called Commandant 4. Years ago I used this on an old car to revive the paintwork. It works very well, but this type of polishing compound is rather coarse. It will remove the top layer of the paint and make it look smooth from afar, but it will actually leave small scratches. These can definitely be seen up close. So use this with care and only as a last resort. It did get rid of the stains on the sheet metal, but besides the small scratches, it also made the surface appear more glossy than the semi-matte that it used to be. I'm not a big fan of this glossy appearance, but at least on video it looks okay. So in summary, would I recommend using this stuff on a CNC machine? The answer is no, because it's too risky and you cannot reverse the process if you're not happy. If you know of any good alternatives, please share them in the comments below. The EMCO lathe still had the original E-stop on the right side of the cabinet. Unfortunately, this was no longer working, so I had to replace this with a new one. Although the controller itself and the MPG have an E-stop button, I think it is good to have one on the cabinet as well, as this is in a natural position and you can have your hand close to it when you're running a program. While I had the panel on the workbench, it seemed like a good time to clean it as well. I replaced the E-stop with a button from the Eaton M22 series. The black switching element mounted behind it is a normally closed contact, which is opened only when the E-stop is pressed. A normally closed contact is used as a safety precaution because you would also get an E-stop situation when the cable to the switch doesn't make proper contact for any reason. As far as I could find, there is no additional input that is designated to be used for an E-stop. Well, there is one, but that's already being used by the E-stop in the MPG. Instead of trying to tap into that wire and connect it in series, I decided to repurpose one of the other inputs on the controller. In order to do this, you can modify the ladder of the CNC controller. A ladder is a very common way to program a controller or a PLC. I am not an expert in this, but I know just enough to be able to modify it. A ladder is basically a program made up of inputs connected in various ways to the outputs to achieve the desired effect. For example, if you want an output to be activated if both button A and B are pressed, you can place the two buttons in series. This means they only give a high signal when both make contact. In another example, if you want the output to be high when either button A or B are pressed, you can place them in parallel. Of course, it's not the same, but you can think of this like an electrical circuit, where the ground is on the left and the plus voltage is on the right side, and the output is a light bulb, which needs to be switched on or off by buttons. Of course, this is not what is actually happening, but connecting a light bulb to buttons in this manner would follow the same logic. I decided to use input M14 for the e-stop, since it was not already in use for my specific application. M14 is called X30 in the controller. I made a connection between the M14 terminal on the I/O board and the negative common terminal, since also this input needs to be pulled to ground to activate it. Here I am pressing and releasing the e-stop, and you can see the input change from high to low and vice versa. So I'm going to edit the ladder now. This will require the entry of a password, which by default is a very simple password. So I would recommend changing this if you're using the controller in a professional environment. What I did was look for all of the instances of X20, which is the input used for the internal e-stop on the front panel of the SZGH controller. I found two instances where this input was used. The idea is to add the newly connected X30 input in parallel with the X20 command, so the external e-stop will copy the behavior of the internal e-stop. I'm going to place the cursor below where I want to insert the block and pick Insert Line. Now I want to add a new block. You can do this by selecting N and type 30 to add X30. Now it's added, and I need to add it to the block above. You can do that by pressing C for a vertical connection. Okay, we will do the same trick on the block below it. Place the cursor below the last block and insert a line. Add a block, type 30 and enter. Also here we need to add a vertical line. If you know anything about ladder programming, you will probably realize that I made a mistake here. We will see that after the reboot. Press C for compile, followed by D to save the ladder. You should be able to activate the ladder so it directly becomes active, but I could not find that menu option quickly, so I just rebooted the controller to reload the ladder. Here we see the issue. The controller is in e-stop directly at startup. This is because I have a normally closed switch on the e-stop, but I mistakenly added a normally open switch to the ladder. So I went back into the menu and replaced the X30 instances by not X30 blocks. The inverse blocks are the ones with the slash. After another save and reboot, the external e-stop works perfectly. There is also free software available to make changes to a ladder program, but for small changes I preferred editing it on the controller itself. Of course, this is not advice on machine safety. Any ladder modifications that you make, especially with e-stops or safety switches, are completely at your own risk. And also make sure that you make a backup of the controller before you start playing around with the ladder logic. So that is it for part 4 of this video series. I hope to see you in the next one, and please leave a like or subscribe to the channel. Thanks for watching.